Good morning, everybody. First, I appreciate Mrs. Kami Machi for allowing me to talk in the webinar. My name is Nguyen Phuoc, working at Ho Chi Minh City University of Technology. My talk focuses on the application of nature-based solutions for sustainable urban water management in Ho Chi Minh City. My talk will briefly present the concept of sustainable urban water management, including sustainable drainage system, water-sensitive urban design. I will introduce key issues related to urban management in Ho Chi Minh City, and finally, I will share two key projects on the application of nature-based solution for urban planning in Ho Chi Minh City. As you know, urban water management involves the planning, development, and management of water infrastructure, including water supply, wastewater treatment, stormwater drainage, and water conservation to ensure the provision of safe and sufficient clean water and sanitation services in urban areas. NBS efficiently contribute to urban water pollution control. The Blue Ring Solutions methodology enables developers and planners to incorporate NBS in a comprehensive strategy to address issues. This includes integrating green spaces, natural drainage, and trees into the urban landscape. Urban planning can benefit from an ecosystem-based adaptable concept that mimics natural water balance and facilitates long-term sustainability. This approach has the potential to enhance livability values for city residents and improve urban biodiversity. The tools for water-sensitive urban design comprise various methods such as vegetative swale, wetlands, bioretention basins, artificial lakes, rain gardens, green roofs, permeable pavements, infiltration wells, and cleansing biotopes. Now I would like to give a brief introduction to Ho Chi Minh City. Ho Chi Minh City serves as economic hub of Vietnam, contributing significantly to the nation's economy. Despite occupying only 6% of the country's total land area, the city is home to 8% of population and accounts for 20% of the country's GDP, 28% of its industrial output in 2020. The rapid rate of urbanization, which is expected to reach higher than 11 million by now, coupled with a population growth rate of 2.7%, presents significant challenges, including environmental pollution, flooding, and insufficient green spaces. The land use pattern of Ho Chi Minh City is characterized by a dominance of agricultural land in the north, urban settlements in the central region, and the presence of the Kenya mangrove forest in the southeast part. Located downstream of the Dong Nai Saigon River system, Ho Chi Minh City has a network of rivers and canal systems, with approximately 170 canals stretching nearly 700 kilometers. The southern metropolis budgets around $48 million annually to maintain its drainage system and approximately $120 million to collect waste. To enhance the appearance of the urban zone and address the persistent problems of flooding and pollution, directing and upgrading the canal infrastructure is a fundamental and sustainable solution. Investing in new large-scale parks has proven to be a significant challenge for the urban greening approaches in Ho Chi Minh City. Currently, the designated land area for ring parks exists at 11,400 hectares, which corresponds to the target of 7 square meters per person. However, the existing park area is only around 500 hectares, which approximates about 5 square meters per person. This is significantly lower than the standard of green space for public usage, which is 12 to 15 square meters per person. Now I would like to present two typical projects related to the relevant research and process based on the application of natural-based solution in Ho Chi Minh City. Asian Development Bank project aimed to mainstream water-sensitive urban design into urban development projects in Vietnam. Ho Chi Minh City is one of the target cities for this project. According to ADB, the water-sensitive urban design tool can be easily incorporated into various urban development projects with typical options including a large open space with waterways, a building unit, civic plaza, and hardscapes such as car parks and roads. In all cases, the presence of the subscapes is crucial for efficient water storage, treatment, and conveyance of multiple purposes, including flood mitigation, runoff harvesting and reuse, heat reduction, and ecological value addition for recreational use. One of the water-sensitive urban design methods suggested by ADB for cities with low-lying land and high-density waterway networks like Ho Chi Minh City is the implementation of the multi-edge treatment. The term edge refers to the boundary between land and water, and it is essential to create a varied sectional profile along this boundary to enhance the social area and environmental values for both people and aquatic wildlife. These typologies provide schematic designs for creating a dynamic waterfront environment. The Go Giap district is situated in the northern region of Ho Chi Minh City Center, where certain canals are contaminated, and there are several flood issues due to the tide and insufficient drainage. ADB has suggested employing soil bioengineering stabilization and designing the flood table stands for the canal banks to construct a beautiful and river interactive park for the Go Giap district community. This floodplain park could mitigate local flooding levels during the storm events. Having been operational for over 20 years, the Tân Bình Industrial Zone now finds itself situated within a densely populated residential area. There is a possibility that it may transform into a residential zone soon. ADB has proposed converting the industrial land use into a high-quality residential neighborhood by adopting a multi-edge treatment design approach for waterways in the Tân Bình district. This plan would address issues such as flooding, pollution, and traffic jam. The picture shows the site of Ban Nguyệt Lake, situated in the residential area of the Phú Mỹ Hưng located in the south of Ho Chi Minh City. The conceptual approach used for this new residential development shares a similarity with the case study sites suggested by ADB for Saint Paul in West City. The incorporation of the steps, platforms, and walkways along the lake edge creates an array of experiences. Moreover, when compared with uptake of the aquatic plants, low-cost water circulation systems hold potential in enhancing the water quality. Now I would like to present the IRD project which focuses bamboo crops as NBS for urban water management. As you know, bamboo crops can be considered as a multi-purpose NBS for the water pollution control in urban water management coupled with urban greening. Bamboo can significantly contribute to urban greening due to its ecological benefits like the carbon sequestration, absorption of particulate matter and nutrients, water and soil conservation. The bamboo application can be a promising approach for water-sensitive urban design. Bamboo can be selected as a potential modified for multi-edge treatment, such as natural edge, vegetative swales, rain garden, and riparian landscapes at the waterfront. Bamboo can be used as the silent erosion control and slope stabilization in urban infrastructures. In our current project funded by French Institute for Research Development, a thicker, smaller leaved bamboo species is called as Bambusa multiplex with fast growth rate was used for the unsaturated vertical contracted wetland at a semi-intensive ring roof to treat rainwater from the office building. After 3 months of running, high performance of COD, nitrogen, and phosphorus removal was observed at loading rate of 300 kg COD per hectare per day in comparison with the control unit without bamboo. There are two conclusions that can be drawn from my presentation. NBS is a potentially effective solution for the wastewater treatment, reuse, and urban green space expansion, meeting the sustainable urban management criteria. The local plants such as bamboo can be selected as potential modifiers for NBS design in sustainable urban water management. Thank you so much for your listening.